Imagine the moon, our celestial neighbor, suddenly drifting closer to Earth. The first thing we'd notice? A dramatic increase in tides. Coastal cities would face unprecedented flooding, reshaping coastlines and ecosystems. The gravitational pull would wreak havoc on our planet's stability, potentially altering the length of our days and the tilt of our axis. Wildlife would struggle to adapt. Nocturnal creatures might find their routines disrupted, while migratory patterns of birds could shift dramatically. And let's not forget the psychological impact on humanity, staring up at a moon that dominates the night sky, a constant reminder of its power. In this cosmic scenario, the moon transforms from a distant dream into a looming giant, forcing us to confront the delicate balance of our existence. What would you do in a world where the moon is no longer just a beautiful sight, but a force to reckon with? To understand the consequences of the moon moving closer to Earth, we first need to grasp the relationship between the two. The moon isn't just a lifeless rock orbiting our planet, it plays a crucial role in maintaining the delicate balance of the Earth. The moon's gravitational pull influences tides, the most obvious impact. The moon's gravity pulls on Earth's oceans, creating high and low tides. Without the moon, or if it were much closer, tides would be dramatically different. Stability of Earth's axis, the moon also helps stabilize Earth's axial tilt, which gives us seasons. Without it, Earth's wobble could become more extreme, leading to climate chaos. Days and nights, the moon slows down Earth's rotation. Believe it or not, days were shorter billions of years ago. The moon's gravitational effect has gradually lengthened our days over time. Currently, the moon orbits Earth at an average distance of about 384,400 kilometers, 238,855 miles. But what if this distance began to shrink? For the moon to move closer to Earth, something monumental would have to happen. In our current reality, the moon is actually drifting away from Earth at a rate of about 3.8 centimeters, 1.5 inches per year. This is due to the complex exchange of angular momentum between Earth and the moon. But what if this process were reversed? Some possibilities could include a catastrophic cosmic event where a massive object, such as an asteroid, could collide with the moon, altering its orbit. Gravitational interference from another celestial body passing close to the Earth-Moon system could pull the moon toward us. There's also the hypothetical technological manipulation. Although currently far-fetched, in the distant future, a highly advanced civilization might be capable of altering the moon's orbit for some unknown reason. Whatever the cause, a closer moon would have immediate observable effects on Earth, effects that would grow more severe the nearer it came. Let's imagine the moon suddenly came closer by 10%, 25%, or even 50%. Each reduction in distance would create increasingly dramatic consequences on Earth. Even a slight decrease in the distance between Earth and the moon would cause a significant increase in the tidal forces on our oceans. With the moon at 90% of its current distance, high tides could be 2 to 3 times larger than they are today. Cities and towns along coastlines would face daily floods, and large regions of land might be permanently submerged, especially in low-lying areas like Bangladesh, the Netherlands, or Florida. The closer the moon gets, the stronger the gravitational forces it exerts, not just on water but also on Earth's crust. This would lead to more frequent and severe earthquakes as tectonic plates shift under increased strain. Volcanic eruptions could become more frequent, especially in seismically active areas like the Pacific Ring of Fire, due to the additional gravitational stress on Earth's mantle. While this could have some benefits in mixing ocean nutrients, it would also make the oceans more dangerous, with currents that could make marine navigation treacherous. As the moon approaches, its tidal forces would slow Earth's rotation even more than it does now. Days would grow longer, perhaps reaching 25 or 26 hours over time, drastically altering life on Earth, from biological rhythms to human work schedules. Another major effect of a closer moon would be its impact on the Earth's atmosphere and weather patterns. The increased tidal forces would affect not only the oceans, but also the atmosphere. This could lead to more extreme weather patterns such as stronger hurricanes, more intense tornadoes, and superstorms that could devastate regions. Storm surges from these weather events would be far worse with larger tides, leading to widespread flooding and destruction in coastal cities. The moon's proximity could also lead to changes in Earth's temperature regulation. The planet's tilt, already sensitive to the moon's position, could wobble more, leading to unpredictable seasonal shifts. Winters could become colder and summers hotter as the planet's climate system struggles to cope with the increased gravitational influence. Life on Earth has evolved under the current conditions with the moon at its present distance. A significant shift in its orbit would have a profound impact on all living things. Many marine species rely on the current cycle of tides for survival. Creatures like crabs, oysters, and certain species of fish time their reproductive cycles with the tides. If tides become more extreme, it could devastate these populations, creating a ripple effect throughout the food chain. Terrestrial animals, particularly those that rely on lunar cycles for navigation, mating, or migration, will be thrown off by the moon's altered orbit. Humanity would face significant challenges adapting to the new world. Entire coastal cities may need to be abandoned due to constant flooding. Agriculture would struggle under new unpredictable seasons and climate shifts, leading to potential food shortages. In addition, the altered day-night cycle, with longer days and nights, would disrupt human sleep patterns, possibly leading to widespread health issues. If the moon were to come dangerously close, closer than 18,470 kilometers, 11,470 miles to be exact, something even more catastrophic would happen. This is known as the Roche limit. The Roche limit is the point at which Earth's gravity would overpower the moon's structural integrity, causing it to be torn apart by tidal forces. Instead of a moon, we would be left with a spectacular but deadly ring systems, similar to Saturn's made up of the moon's debris. However, this event would shower Earth with millions of meteor-like fragments, devastating the surface. The debris would rain down, causing massive destruction, widespread fires, and possibly triggering a planet-wide extinction event similar to the asteroid impact that wiped out the dinosaurs. If the moon were to drift closer to Earth, the consequences would be catastrophic. Imagine tides swelling beyond their limits, flooding coastlines and altering ecosystems. Our climate would shift dramatically, leading to unpredictable weather patterns. In the worst-case scenario, this could even threaten life as we know it. Yet, this thought experiment highlights the fragile balance of our solar system. The moon, seemingly silent and distant, is crucial for stabilizing our planet's tilt and regulating tides. It's a reminder of the intricate dance of celestial bodies that allows life to flourish here. So as we look up at the night sky, let's appreciate the moon for what it is, a constant, reassuring presence that keeps our world in harmony. So, the next time you look at the moon, remember, it's not just a glowing orb in the sky. It's a vital part of Earth's history and its future. Who knows what other mysteries our moon holds? Thank you for watching this video. If you enjoyed it, don't forget to like, subscribe, and hit the notification bell for more fascinating content from Amazing World Facts. Stay curious, stay amazed, and see you next time.